Children, let us continue the chapter Coordinate Geometry. Now let us solve the first exercise, which is based on distance formula. That is the exercise 1 of the chapter. Now the first main question, what is that question? Find the distance between the following pair of points. First one is 2, 3, 4, 1. Second one is -5, 7, -1, 3. Third one, AB minus A minus B. Now let us find the distance between the first pair of points. To take that one, let us consider the points are P and Q. Let the points are P and Q, that is P of 2, 3 and Q of 4, 1. P of 3 and Q of 4, 1. Now let us consider this is x1, y1. This is x2, y2. P of x1, y1, Q of x2, y2. They are P of 2, 3, Q of 4, 1. The coordinate of the points P are 2, 3. Coordinates of the point Q is 4, 1. Now you write the distance formula. The distance between the points P and Q is PQ, that equals x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance formula of the points P and Q whose coordinates are x1, y1, x2, y2 respectively. Now PQ equals whole root. Write the value of x2, x1, y2, y1. x2 is 4. 4 minus x1 is 2. 4 minus 2 whole square plus y2. y2 is 1. 1. y1 is 3. 1 minus 3 whole square. Now PQ equals whole root 4 minus 2 whole square is 2 square. 4 minus 2 is 2, 2 square plus 1 minus 3. 1 minus 3 is minus 2 whole square. Then PQ equals, you got 2 square value is 4, minus 2 whole square value is also 4. 2 into 2, 4, minus 2 into minus 2 is also 4. Then you got PQ equals 4 plus 4, 8. You can write root 8 as it is, or otherwise you write PQ equals root 8 is 4 into 2, root 4 into 2 equals root 4 is 2 root 2. So root 8 you can write it as 2 root 2. The next one is find the distance between the points -5, 7 and -1, 3. Now you consider, let P of -2, -7 and Q of -1, 3. Now these are the coordinates which represents x1, y1. These are x2, y2. Now you write the distance formula. PQ equals whole root x2 minus x1 whole square plus y2 minus y1 whole square. Then PQ equals whole root x2 is -1 minus x1 is -5, you write -1 of -5 whole square of this. x2 is -1 minus of -5. x1 is -5. Then plus y2 is 3. y1 is 7. y2 is 3. y1 is 7. Right? 3 minus 7. y2 minus y1, 3 minus 7 whole square. Then PQ equals whole root minus 1 minus of minus plus minus of minus plus plus 5 whole square plus 3 minus 7, 7 minus 3 is 4, 3 minus 7 is minus 4 whole square. Then PQ equals minus 1 plus 5 means that is 5 minus 1. So it is 4 square plus minus 4 whole square. PQ equals 4 square is 16 minus 4 whole square is also 16. Then you write PQ equals 16 plus 16, root 16 plus root 16 plus 16. So you got root 32. Then PQ equals, you can write 632 is the product of square number into some other number, that is 16 into 2. Then you can write PQ equals square root of 16 is 4. You write it 4 root 2. 4 root 2. So the distance between the points minus 5 7 and minus 1 3 is 4 root 2. Next, distance between AB and minus AB. Then you consider, let P of AB and Q of minus A minus B. Then you write PQ equals the distance formula. First you consider this is x1 y1 and the coordinates of Q are x2 y2. Write the formula PQ whole root x2 minus x1 whole square plus y2 minus y1 whole square. Then PQ equals x2 minus x1, x2 minus x1, x2 is minus a is x1 is a. So you write minus a whole square of this plus y2 is minus b, y1 is b minus b whole square. Then it is PQ PQ equals whole root minus a is minus 2a whole square plus minus b is minus 2b whole square. Then it is PQ equals whole root minus 2a whole square is 4a square plus minus 2b whole square is 4b square. So the distance between the points P and Q is whole root 4a square plus 4b square. And also you can write PQ equals, it is 4, you can remove as a common. In the bracket you will get root a square plus b square. Then PQ equals root 4 is 2. Take it outside as a root. So it is 2 whole root a square plus b square. 2 whole root a square plus b square. Then the second question, find the distance between the points 0 0 and 36 15. Here the coordinates of one point is 0 0, then it is a origin. You know that coordinates of the origin are 0 0 and the other one point is 36 15. You can use the distance formula between the 2 points P and Q, or also you can use the formula between the points origin and a point. So you consider the 2 points P of 0 0 and Q of 36 15. Then it is x1 y1, x2 y2. Or if you consider the distance between the origin and a point, then you can have P of 0 0 and Q of 36 15 as xy. That also you can do here. 36 15. So if you use x1 y1 x2 y2, you can write the relation or the formula pq equals whole root x2 minus x1 whole square plus y2 minus y1 whole square. Or if you use the origin and the coordinates are xy, then you take pq equals what? Whole root x square plus y square. Both are same here. Now let us write, that is pq equals, that is nothing but p is a origin here, the point is o, origin, and this point let us take the point p, then this becomes op. You can also take pq and also op, anyone you take. So now let us write op. op equals whole root x square plus y square. op equals whole root x square plus y square equals op equals whole root x square, that is 36 whole square plus 15 whole square. X is 36, y is 15. op equals whole root 36 square is 36 into 36, that is 1296 plus 15 square, 15 into 15, 225. Then find the sum of 1296 and 225. 1296 plus 225. Then you got 6 plus 5, 11, 9 plus 3, 12, 5, 1, 5, 2, 1. So you write OP equals square root of 1521. 1521. Then find the square root of 1521. Then use the division method. Then you make the group. The nearest perfect square to 15 is 9. That is 3 3s are 9. 4 4s are 16 becomes. So you take 3 3s are 9 and you add 3 here, that becomes 6. 15 minus 9 is 6. Then take down that 21. You got 621. Now you write some number in front of 6. Here it is 21, means either you have to put 1, 61 or 69. You take 61 into 1, 61 you will get. 69 into 9, 9 9s are 81. 9 6 are 54 plus 8, 62 you will get. So you put 9, 9, 69 9s are 621. You got 0. Subtracting 621 by 621. You got 0. Therefore you can write OP equals, what is the square root of 1521? You got it, 39. 39 is the square root of 1521. Therefore the distance between the points 0 0 and 36 15 is 39. Or you use this P and Q, x1 y1 x2 y2. Take if P of 0 0 and Q of 36 15. If it is x1 y1, it is x2 y2. You can use any one method. Then PQ equals whole root x2 minus x1 whole square plus y2 minus y1 whole square equals whole root x2 is 36 minus 0 whole square plus y2 15 minus 0 whole square. Then also you got same 36 square plus 15 square. So PQ equals 36 square, you know already, 1296. Square root of 1296 plus 225. The sum is PQ equals, you got 1521. Its root is 39. Third question. Determine if the points 1, 5, 2, 3 and minus 2, minus 11 are collinear. You know what do you mean by collinear? If the points lies on a straight line. then that points are said to be collinear points. If they are collinear means sum of any two sides must be equals to the third side. So if you consider this is A, this is B, this is C, or you can also take P, Q, R. Then sum of any two sides will be equals to the third side if they are collinear. If the sum of any two sides is not equals to third side, then you can say that they are not collinear. They forms the sides of the triangle. Now let us take P is a point, its coordinates are 1, 5. Q is a point, its coordinates are 2, 3. And R is a point with coordinates -2, -11. Also we can take A, B, C. Here we have taken PQR. Now you point PQ. Here to find PQ you take the points P and Q. To find PQ, you take P is a point of the coordinates 1, pi, and Q is a points of the coordinate 2, 3. So these are x1, y1, these are x2, y2. Then write the distance formula. PQ equals x2 minus x1 whole square plus y2 minus y1 whole square. Then PQ equals x2 is 2, x1 is 1. So it is 2 minus 1. Then y2 is 3 plus y2 is 3 and y1 is 5. So it is 3 minus 5 whole square you put. 2 minus 1 whole square plus 3 minus 5 whole square. And PQ equals 2 minus 1 is 1, 1 square. Then 3 minus 5 is minus 2 whole square. Then you write PQ equals 1 square is 1 plus minus 2 whole square is plus 4. Minus 2 whole square is 4. So PQ equals root 5 you got. PQ equals root 5. Then you take, next you find QR. You have to find PQ equals, QR equals and PR equals. So find that. You got PQ now. Now you get QR. To find QR. So you take the point Q and R. What are the coordinates of the Q? 2, 3. And coordinates of R are -2, 11. -2, 11. Points are Q and R. Coordinates of Q are 2, 3 and coordinates of R are -2, 11. Now you write QR. Here the points are Q and R. So you write QR. Now you consider this is x1, y1, x2, y2. Then you write the distance formula. That is x2 minus x1 whole square plus y2 minus y1 whole square equals QR equals whole root x2 is -2 and x1 is 2. So -2 whole square plus y2 is 11, y1 is 3 -3 whole square. Then you write QR equals, what you got? -2. Sum of -2 and -2, they are having same sign. Their sum is -4. So you write -4 whole square plus 11 minus 3 is 8 square. So you got 8 square. Then it becomes QR equals minus 4 whole square, 16 plus 64 you got. 16 plus Q is a point with coordinates 2, 3 and R is a point with coordinates minus 2, minus 11. Then you write the distance QR, distance formula you write, equals x2 minus x1 whole square plus y2 minus y1 whole square. Then QR equals x2. Here we have considered this is x1, y1. These points are x2, y2. x2, y2. So QR equals whole root x2 minus x1, that is minus 2, minus 2. Minus 2, minus 2 whole square. y2 minus y1, y2 is minus 11, y1 is 3, that is minus 3. y2 minus y1, minus 11 minus 3 whole square. Then you write QR equals whole root, sum of minus 2 and minus 2 is minus 4 whole square, and sum of minus 11 and minus 3 is minus 14 whole square. Minus 14 whole square. Then it is whole root minus 4 whole square is 16, minus 14 whole square is 196. So you got QR equals square root of 212. Square root of 212. To find PR. So P is a point of the coordinates 1, 5 and R is a points of coordinates. R is a point of coordinates minus 2, minus 11. So write 1, 5 minus 2 minus 11, 1, 5 and R minus 2 minus 11. Minus 2 minus 11. Then find the distance between P and R, that is PR equals whole root, this is x1, y1, x2, y2. Write the formula, x2 minus x1 whole square equals plus y2 minus y1 whole square. Then PR equals whole root, x2 is minus 2 minus 1 whole square plus y2 minus 11, y1 is 5, minus 11 minus 5 whole square. Then PR equals whole root, sum of minus 2 and minus 1 is minus 3 whole square plus sum of minus 11 and minus 5 is minus 16 whole square. Then PR equals minus 3 whole square, you got, that is 9, plus minus 16 whole square is 16 into 16, 16 square is 256. Then sum of 9 and 256. Sum of 9 and 256 is 263. So PR equals, here you find a PQ plus QR and also PQ plus PR and also PR plus QR. PR plus QR and PQ plus QR. What is PQ? PQ is root 5, QR is root 212. Root 5 plus root 212 and PQ is root 5, PR is root 65 and PR is roots 265 plus QR is 212. Root 212. Now here what you can observe, PQ plus QR is not equals to PQ plus QR is not equals to PR, and PQ plus PR, what is the remaining side here? If you take PQ and QR, the remaining side is PR, and if you take PQ and PR, then the here not equals, and PQ plus PR is also not equals to PQ. PQ plus PR is not equals to QR, and PR plus QR is also not equals to PQ. As sum of two sides is not equals to the third side, the given points are not collinear. You will get a triangle by joining the 3 points. So you can write, therefore the points are not collinear. Here sum of two sides is not equals to third side, because root 5 plus root 212 will not, that is not equals to root 265, and also root 5 plus root 265 is not equals to root 212. Root 265 plus root 212 is not equals to root 5. That is PQ plus QR is not equals to PR, PQ plus PR is not equals to QR, and PR plus QR is not equals to PQ. Sum of two sides is not equals to the third side. Therefore, the points are not collinear. 3 points are the points P, Q and R are P, Q and R are not collinear. They may form the triangle. The fourth question is, check whether 5 minus 2, 6, 4 and 7 minus 2 are the vertices of an isosceles triangle. Here 3 points are given. We have to check whether they are the vertices of an isosceles triangle or not. Now you take, let A is a point of vertices 5, 2. You can take PQR also. B is a point of vertices 6, 4, and C is a point of vertices 7, minus 2. Then find AB, BC and CA and verify whether two values are equal or not. Now you get AB. To find AB, you take the 2 points A and B. A 5 minus 2 and B 6, 4. The coordinates you take x1, y1, x2, y2. Then find AB. AB equals whole root x2 minus x1 whole square plus y2 minus y1 whole square. AB equals whole root x2 is 6, x1 is 5, x2 minus x1 means 6 minus 5. 6 minus 5 whole square plus y2 is 4, y1 is minus 2. So that is 4 minus 2 whole square. 4 minus 2 whole square, you write. Then AB equals whole root 6 minus 5 is 1 square plus 4 minus of minus 2 is 4 plus 2 whole square. Then AB equals whole root 1 plus 4 plus 2 6 whole square. So AB equals 1 plus 6 square is 36. So you got AB equals 37. 36 plus 1 is 37. Now you consider this is the first value. Then to find BC, you got AB, then you to find BC, you write BC. To find BC, consider the point B. B is a point with coordinates 6, 4 and C is a point with coordinate 7, minus 2. Then find BC, you write this is x1, y1, x2, y2. Then BC equals whole root x2 minus x1 whole square plus y2 minus y1 whole square. Then BC equals x2 is 7 minus 6. 7 minus 6 whole square. x2 is 7, x1 is 6 plus y2. y2 is minus 2 minus 4 whole square. So BC equals 7 minus 1, you got 1 square plus minus 2 minus 6, you got minus 2 minus 4, you got minus 6. Sum of minus 2 and minus 4 is minus 6 whole square. Then BC equals whole root 1 square is 1 minus 6 whole square is plus 36. You got that is also 37. Here only you can conclude two sides are equal. So you can write that from first and second. No necessity to find the third one. From first and second, AB equals BC. Therefore 6, 5 minus 2, 6, 4 and 7 minus 2 are the vertices of isosceles triangle. Fifth question. In a classroom, 4 friends are seated at the points A, B, C and D as shown in the figure. Champa and Chameli walk into the class and after observing for few minutes, Champa asks Chameli, "Don't you think ABCD is a square?" Chameli disagrees. Using distance formula, find which of them is correct. Here 4 students are there, 4 friends are there. They are sitting at a points A, B, C and D. A, B, C and D. And we have to check whether it is a square or not. First you get the coordinates of the point A, B, C and D. So A is a point with the coordinates. Find the coordinates here. We will get the coordinates are 3 and 4. X coordinate is 3 and Y coordinate is 4. 3, 4. And coordinates of the B. B is a point with the coordinate. Take here, come to straight to X and the point is straight to 7. So the coordinates are 6, 7. Then the coordinates of the C, here X is 9 and Y is 4. So C is a point with the coordinate 9 and 4. Then D. Then D is a coordinate with the point 6 and 1. D is a point with the coordinate 6 and 1. The coordinates of the point 6 are 6 and 1. So you got the coordinates of 4 points. Now you find AB, BC, CD, DA. First you find, to find AB. To find AB, so you take the points A and B. A 3, 4 and B 6, 7. Then x1, y1, it is x2, y2. Then you write AB equals whole root x2 minus x1 whole square plus y2 minus y1 whole square. Then you get AB equals x2 minus x1 is 6 minus 3. 6 minus 3 whole square plus y2 minus y1 is 7 minus 4. So you write 7 minus 4 whole square. Then AB equals 6 minus 3, 3 square plus 7 minus 3 also 3 square. You got AB equals 3 square plus 3 square, 9 plus 9, you got 18. AB you got root 18. Then next let us take, you can convert this as a this is a product of square number into some other number. 9 into 2, 9 is a square number. Then you can write 3 root 2. The square root of 9 is 3. So you can write 3 root 2, or otherwise you can keep it as square root of 18. Next you take BC. BC, to find BC, BC, B is a point with the coordinate 6, 7 and C is a point with the coordinate 9, 4. So write 6, 7 and C is a point with the coordinate 9, 4. Then you find BC. BC equals, write the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. Then BC equals square root of, you take this x1, y1, this is x2, y2. Then x2 minus x1 is, x2 minus x1 is 9 minus 6 whole square plus y2, y2 is 4 minus 7. y2 minus y1 is 4 minus 7 whole square. Then BC equals whole root 9 minus 6, 3 square plus 4 minus 7, that is also minus 3 whole square. Then you got BC equals 9 plus 9. 3 square is 9, minus 3 whole square is 9, that equals root 18. Again you got it as square root of 9 into 2, that equals 3 root 2. Now here this is the first one you got and this is the second one. Then you find AB you got, BC you got, then you find, to find AB, BC is over CD. So C is a point with 9, 4 and D is a point with 6, 1. So C 9, 4 and D 6, 1. D is 6, 1. Then you find DC, CD or DC. So write CD equals x2 minus x1 whole square plus y2 minus y1 whole square. This is x1, y1, x2, y2. Then you write CD equals whole root x2 is 6 minus 9. x2 minus x1 is, x2 minus x1 is 6 minus 9 whole square plus y2 minus y1 is 1 minus 4. 1 minus 4 whole square. Then CD equals 6 minus 9 you got it minus 3 whole square plus 1 minus 9, 4 is also minus 3 whole square. Then CD equals square root of 9 plus 9. Root 3 whole square is 9. Root 3 whole square is 9. So you got again root 18, that equals 9 into 2. Square root of 9 into 2 equals 3 root 2. It is also considered, that is the third. You also got 3 root 2. Next one, dA. dA. To find dA, D is a point with the coordinate. What are the coordinates of the point D? 6, 1, you know it. And A is a point with coordinate 3, 4. So you write dA or AD. dA equals whole root x2 minus x1 whole square plus y2 minus y1 whole square. Consider this is x1, y1. This is x2, y2. Then dA equals whole root x2 is 3, x1 is 6, x2 minus x1 is 3 minus 6 whole square plus y2 minus y1 4 minus 1 whole square. Then dA equals, you got 3 minus 6 is minus 3 whole square plus 4 minus 1 is 3 square. Then dA equals 9 plus 9 you got, that equals root 18. Again you got, that is 9 into 2, square root of 9 into 2 equals 3 root 2. So this is the fourth one. Then from first, second, third, fourth, you observe that all are same here. 3 root 2, 3 root 2, 3 root 2, 3 root 2. Then also find the diagonal. Here you got AB, BC, CD, DA of the same length. Now you find the diagonal. If diagonals are equal and all the sides are equal, then you can conclude that ABCD is a square. Now you find AC and BD. To find diagonal AC, what are the coordinates of A? 3, 4 and C 9, 4. C is 9, 4. Then find AC. AC equals, you write whole root x2 minus x1 whole square plus y2 minus y1 whole square equals, this is x1, y1, these are x2, y2. So x2 minus x1 is 9 minus 3. Here 9 minus 3. 9 minus 3 whole square plus y2 minus y1. y2 is 4, y1 is also 4. That becomes 4 minus 4 whole square. Then AC equals 9 minus 3 is 6. 6 square plus 0 square. So AC is equals to 36 plus 0. You will get root 36. Root 36 equals 6. Then find the diagonal BD. To find BD, what are the coordinates of B? 6, 7. B is a point with the coordinate 6, 7. And D is a point with the coordinates 6, 1. 6, 1. Then write the distance BD is equals to x2 minus x1 whole square plus y2 minus y1 whole square. y2 minus y1 whole square. Then you take equals whole root x1 y1 x2 y2. So x2 minus x1 means 6 minus 6, 0. 6 minus 6 whole square plus y2 minus y1 is 1 minus 7 whole square. That equals whole root 0 square plus minus 6 whole square equals, it is 0 plus 36. You got BD is also is equals to root 36, which is equals to 6. Then AC you got 6, that is consider that is the fifth one. Then BD you got 6, that you consider sixth one. Then first, second, third, fourth, you know. First one is 3 root 2, that is AB. Second one is also 3 root 2, that is BC. Third one is also 3 root 2, CD. And fourth one is also 3 root 2, that is DA. So you got that AB equals BC equals CD equals DA, that is from first, second, third, fourth. And also you got from the fifth and sixth, AC and BD, the diagonals are equals. As all the four sides are equal and diagonals are equals, so you can conclude that ABCD is a square. So write from first, second, third, fourth, AB equals BC equals CD equals DA, all are equals to 3 root 2. And from fifth and sixth, these are the sides. Diagonal AC equals BD, they are equals to 6. Therefore, as all the sides are equal, and diagonals are equal, ABCD is a square. ABCD is a square. Who is correct here? According to the question, here Champa asks Chameli, don't you think ABCD is a square? So here Champa is correct. Champa is correct. Therefore you write what you have to write. Therefore Champa is correct. Hence Champa is correct. Hence Champa is correct. This is the answer.